Hello, we've been looking at the windows, and today we are going to look at everything that is surrounding the window. So that will be the lintel above the window and the embrasure on the sides, the sill below the window, and balconies. If we have a very big window going down to the ground, then I could have a balcony in front of it. So by today's standards, window frames have to be thermally separated. In the case of wood, this can be accomplished with the wood itself because it has a certain insulating value. In case of metal, for example, steel or aluminum here, this is not possible. So this is an old window frame which could not be used today anymore. And you can see that by today's standards, these window frames here are thermally separated with a PVC layer, that's the black parts here, inserted in the frame. And in the case of the plastic window, you can see that it has been reinforced with steel, but the insulation is done on the outside with the plastic elements. So here for this window wall profile, that's the same. Here I have the insulating level, although in this case we don't have an insulating glass. Here exactly the same for a different type of exterior aspect. So thermal separation is at this level here. So here we have a section through a curtain wall containing sandwich panels, which are filled with insulating material, and we have outside metal, inside metal. You can see that this is inserted at the same level as the insulating panels. And here we have the Sills solution here, where the last profile will arrive just above the soil and then be visible on the inside. You can see that the transom here is not as high as the mullion. Here we are using a mullion profile for the sill again. So a particular way to open a window is the sliding window. You can see that the interior part here can be slided behind this part, but that means that the thermal insulation level is changing levels here inside the facade, and this requires particular detailing for the top, the side and the middle of this sliding window. But most firms that offer window profiles are offering sliding window profiles as well. So we've been talking about massive brick walls, and this is a lintel for a massive brick wall. So you can see that there are U-shaped brick elements, and these are filled with concrete, and there's a rebar sticking out in the lower area where the tension would be. In the middle there is a insulation block as to improve the thermal insulation of the lintel itself. So for wider opening we could use this type of lintel where the U would be filled with concrete and rebars, and so you can add this opening up to 3 to 4 meters by conceiving a horizontal beam in the upper part. Here we have a roller shutter casing incorporated in the lintel. You can see the rebars here sticking out on each side, and you can see an additional thermal insulation, which means that the barrier between hot and cold is taken around the roller shutter on the inside. And to operate the roller shutter I need a band, and this band can be cased in a special casing here, as for example this one, which would be incorporated on the side of the window in the embrasure. In this case, the wall is rather deep, and you can see that the sun protection is disappearing above the window as well. So in this case, the sun protection here is in front of this small section of curtain wall facade, and on the other side you can see a flush window in a closed wall, and thus there was not the possibility to find a casing for the sun protection above the window, so it had to be housed inside the window itself. Behind me, quite a nice sun protection textile, so it's sort of projecting out. It's called Markisoletten in this part of the world. And below that you can see windows that are flipping out. So in this case you can see that the window has a stop because the frame is much wider from the inside than at the outside. And on the outside here you can see the concrete, and on the inside you see the wooden frame. So this is a stop for the window, and it's fixed laterally with these screws. So this is what I have been showing to you from the inside. You can see that from the outside you can see only a very small portion of the window frame, but from the inside it was a prefabricated concrete panel here on my left hand side. So in these two walls we have a window which is more or less flush with the outside, and on the other side one which is in the middle of the wall. And the middle of the wall is the thermally preferable position. You can see that in the depth of the embrasure you are able to house protective devices, as these louvers that you can see over there. So behind me we have a cavity facade in brick, so interior load-bearing bricks and exterior cladding with bricks. So behind that we have an air layer. The evacuation intake of the air are visible in the facade. And above the opening there's a sort of lintel. Well, this lintel only supports the bricks above it, but not the load of the floor slabs on the inside. Those are completely thermally separated at the window level. So two older buildings with flush windows inserted in the brick and concrete facade. So in this case I suspect the floor slabs to be visible on the outside. So in terms of thermal conductibility, that's rather bad. And you can see that putting the windows flush necessitates interior shutters. They are cased inside the glazing. Same at the other building behind me, where we have a roller type of solar protection device which is also inside the glazing. So at the same building on the sides we have a variation. You can see the regular brick facade, and under these openings here we have metal panels as a facade cladding. Here the sill is a little dirty, but otherwise it works quite well. This can be at level with the exterior cladding because it's metal and metal, so we won't risk any stains. And there are the louvers that can be cased in the depth of the facade above us. So this is not beautiful, but it's working quite well. It's the window in the middle of the facade. You can see a niche for the louvers on top of the window, and you can see here the windowsill sticking out in front of the facade. This is about 4 to 5 centimeters in front of the facade with the drip and the lateral reveal that avoids water from building stains along the sides of the window opening. Here the question of overhang of the windowsill has been exaggerated a little bit. These are 8 centimeters, so we only need 4 to 5. So you can see that this window opening has been repaired. Well, first of all, there have been putting in plastic windows, and here we have a windowsill which is in 2 pieces, as to avoid this type of failure. Because the sun shines on the windowsill, then this thing expands and retracts, and if it is fixed to the embrasure, then it will tear out little pieces of stucco. So this is very often critical part of the window. So you can see that if the reveal is missing, you have stains on the side of the window. So the exterior sill here is quite inclined. That's pretty good, but much less would be sufficient. You can see there's a drip here. It is slightly in front of the facade level, and you can see this reveal here on the side. So the reveal avoids that under certain conditions water is dripping off against the facade and then will produce stains along the facade. So 2 types of window sills here, less inclined than above, as you can see. And here the architect has been working with the corresponding casing for the louvers, sun protection, in the depth of the brick cladding of the facade. So a particular problem of today's window sills is the exit to a balcony, and many people do not walk well these days. Others are using rolling chair, and so the bottom of the window should be going down to the level where you walk or you roll on. And as to be sure that the window is waterproof at this spot, I need a gutter, and on top of this gutter I can put a grill, so that we will have continuity between the level of the inside and the outside. So below me you can see the end level from the inside to the outside, with a gutter in between, and the gutter has been closed with a grill. So for the door you can see that it's approximately in the same position. There's a little reveal here that stops the water from entering the building. But if we would want to do this right, we would introduce a gutter here with a grill on top of it, so that the water can be evacuated even in case of strong wind coming against the door. So you can see that in this case the entry is protected by a roof above me. Don't go there. And there's a sort of water evacuation below as well, so the water cannot get to the door itself. That's a much better solution than what we have been seeing before. So if I want to have a balcony in concrete as the continuation of a floor slab, I need one of these elements, which is called an isocorp. That's a brand-specific delineation. So it's an insulating element. You can see the insulation here, and you can see that here the rebars are out of stainless steel, because stainless steel rebars are much more insulating than normal steel is. It's about 1/4 of a normal steel bar. This is why they are made out of stainless. And you can see there's the tensile element on top, and there's the compression here at the bottom. So if this thing sticks out, there's tension in the upper part of the balcony and compression in the lower part. So behind me we have the balcony, which is separated by the thermal insulating element, and we can see the big pipe coming out of the balcony evacuating rainwater. So these exterior balconies can be waterproofed with waterproof concrete as well. So this doesn't necessitate separate waterproofing, but the water has to be evacuated because otherwise it will be going down on the people living below you. So you can see that this is a facade that has been insulated afterwards. So here we have a stuccoed insulation which has been added to the facade. And so I suspect these balconies to be equipped with isocorp as well, which means thermal separation at the layer of the insulation, as to allow the balcony to be attached to the floor slab and be insulated at the same time. Two types of balconies behind me, and I would suspect both of them to be in direct link to the floor slab behind, so there must be a massive thermal bridge from the outside to the inside. So the building behind me is a particular case because it has these cantilevers sticking out of the facade at the bottom, and you could imagine that the balconies could be cut from the floor slabs behind it because they are sitting on the cantilevers at the ground floor. So behind me we have a refurbishment measure where the existing loggias have been closed by a new glass level, which is improving the facade in thermal terms. The volume becomes more compact, and it also in acoustic terms, because now I have double glazing instead of simple glazing. So in certain cases this might be a solution for the balconies as well. Particular kind of balcony behind me is the loggia, which is kind of inserted in the facade level. For a useful balcony you need about 1.80 meters depth, maybe 1.50 meters, but that's quite small already.